Hello again. Now we're on to increasing and decreasing functions. Okay, so first of all, if you look closely here, a function is decreasing when the gradient of the curve is negative. So at this particular one here, at that point there, the function is decreasing because it has a negative gradient. And if we look onto this one, at this point here, the function is said to be increasing as it has a positive gradient. So if we're interested in the time or the particular values that the function is increasing or decreasing, we are wondering when the gradient dy by dx is less than 0 for decreasing, and the function will be increasing for any values of x where dy by dx is greater than 0. So in a nutshell, if you're asked to find the range of x values for which a function is increasing or decreasing, you will differentiate and solve the inequality dy by dx greater than 0 for an increasing function, and for a decreasing function, solve dy by dx is less than 0. As you know, with inequalities, the answer to an inequality is a range of values, and it will be a range of values for x, and it will be, well, depending on which way you've set the inequality, the solution to the inequality will be the range of x values for which the function is either increasing or decreasing. So here we have a quadratic, and so for what values of x is the function 2x squared add 4x add 5 an increasing function? Okay, well that would be when the gradient, that would be the range of x values for which the gradient is positive. So we'll find dy by dx because that's our gradient function, which is 4x add 4. Y is increasing when dy by dx is greater than 0, so I'm going to set dy by dx, which is 4x add 4, to be greater than 0. If I solve that quite straightforwardly, you will get x is greater than minus 1. So for this quadratic, we are an increasing quadratic, we're an increasing function for all the times that our x values are greater than minus 1. And if you look at this sketch, that makes sense because the turning point here is at minus 1, whatever that point is there. And we've got points, point, increasing, steeper increase, but still increasing, even steeper. And then to the left of that, as in less than minus 1, we would be a decreasing function. Because if we were interested in a decreasing function, we would have set this up less than 0, and it would have been x is less than minus 1. So that's basically it. So for number 2, we've got a cubic function. So f of x is x cubed, take 2x squared add x add 5, and when we're interested in when it's a decreasing function. And so if we differentiate, we get f dash x is 3x squared minus 4x add 1. And so we will be decreasing when f dash x is less than 0. So if we solve this inequality, you can use your calculator straight away to do that. The range of x values for which this cubic is decreasing is when x is between 1/3 and 1. And so it must go something like that, and that x coordinate has 1/3 and this x coordinate has 1, because between those values, as in this part here, it's decreasing. Everywhere else it's increasing. And so if you'd have set that inequality the other way, it would have been that x must be less than 1/3 and x must be greater than 1. Okay, I hope that's okay. I'll set you some questions. It may or may not be those, so don't pay too much attention to that. And yeah, on to the next video.